In previous lecture, we have taken one numerical of slope deflection equation. Today, we'll continue with our next numerical. I have taken a continuous beam ABC whose loading is same as this previous numerical, but only what I have changed the support conditions over here. Okay, so in previous numerical at support A, you are having a fixed support over there. Now what I am taking, I have considered a hinge support at this place. So what changes will be there in numerical, that we are going to see here. Okay, so we have to analyze the continuous beam ABC using slope deflection equation. So we'll start for the analysis process. Our step number 1. What is the step number 1? In that we'll calculate the degree of kinematic indeterminacy, that is dk. Dk, it is the based on the support conditions over there. So at support A you are having hinge support, so dk at this place will exist. At support B it is a simple support or roller support, so here also your dk value will exist. And at C there is again a roller support, so here also your dk value will exist. So all these three supports you will be having dk value. So total dk value, that is number of, we'll call these as number of unknown displacements, those are equal to 3. Okay, so which are those? Those dk values are theta at point A, suppose assuming as a clockwise rotation, second theta B, and third value, that is theta. Okay, so these three will be our basic unknowns that we have to find out, or this will be our claim of the numerical, that values we are going to find out. Then we'll proceed to our step number 2. Step number 2 will be calculating fixed moments. Okay, so fixed moment. While calculating this fixed moment, what we do, we consider all joints as your initially fixed one. So fixed moment for your first span, that is span AB, you will be having MFAB. MFAB, that is equal to, considering these two joints as your fixed one and fixed loaded with a uniformly distributed load throughout the span, your fixed moment value comes equal to WL square divided by 12. Okay, and considering its restoring sign or restoring nature, we get it negative. Okay, so that comes equal to WL square upon 12, that is minus 10 into L is your 4 for member AB divided by 12. So that comes equal to, if you calculate, 13.33 kilonewton meter. Next, MFBA. So again completely loaded with the UDL of a fixed span, so that will come again WL square upon 12. Only what will happen, its nature of restoring will be clockwise, so that comes equal to plus 10 into 4 square divided by 12, that is same value will get but of opposite nature, 13 kilonewton meter. Right, then we'll go for the next span, that is your span BC. Considering again both the joints as fixed one, so we'll calculate next fixed moment, that is MFBC. So loading in span BC, non-uniform load of 12 kilonewton at non-uniform distance, that is at 4 meter from B and 2 meter from C. So MFBC, that comes equal to minus WAB square divided by L square, where A is your 4 meter and B is your 2 meter. So that comes minus load is your 12 into 4 into 2 square divided by total length is your 6 square. So that comes equal to minus 5.33 kilonewton meter. You calculate and then see this. Okay, next fixed moment, MFCB. MFCB, that comes equal to plus WA square B divided by L square. You have to not interchange your values of A and B. A will remain 4 and B will remain as 2 itself. Okay, so this comes plus 12 into 4 square into 2 divided by 6 square. So this value comes equal to plus 10.67 kilonewton meter. Right, so this will be all your fixed moments for joint A, joint B and joint C, considering as Please stand by. Now we'll move to your next step, step number 3, that is your slope deflection equations. Okay. So for first member, that is MAB, we get slope deflection equation, that is MFAB. I'll write directly values over here. So MFAB, we are having minus 13.33. Okay, so minus 13.33 plus 2EI upon L of member AB is your 4 meter, into bracket near end rotation, that will be your 2 times of theta A plus theta B. Here delta value or delta concepts are not given over here, that is any support is sinking or displacing by some amount. So your delta value in this equation will remain 0. So last term, that is minus 3 delta upon L, that will become completely 0, and this will form your basic equation for MAB. We'll modify this, that is minus 13.33 plus 2 by 4, that is equal to 1 by 2, that is equal to 0.5 times of EI, 2 times of theta A plus theta B. That will be your equation for member AB. I'll call it as equation number 1. Okay. Next we'll see for your next member, that is BA. So MBA, that comes equal to MFBA, that I am getting equal to MFBA minus plus 13.33 plus 2 EI upon L, that I'll get again 0.5 times of EI into bracket. What will happen now? Only your near end and far end will get interchanged. So that comes here equal to theta A plus 2 times of theta B. This I'll call it as equation number 2. That is your slope deflection equation for B. Right. Next we'll see the slope deflection equation for your next span member, that is MBC. Okay. So MBC comes equal to MFBC, that we have calculated here. MFBC is minus 5.33 plus 2EI upon L. L for what? L of member BC, that is 4 plus 2 equal to 6 into bracket. Near end will be now your B, far end will be C. So here it comes 2 theta B plus theta C. We'll modify this. So MBC will get equal to minus 5.33 plus 2 by 6, that comes equal to 0.33 times of EI into bracket 2 theta B plus theta C. I'll call it as equation number 3. Okay. And last joint, that is MCB, that will be our last member. So MFCB that I have got equal to plus 10.67 plus 2 EI upon L, that I'll get equal to 0.33 times of EI into bracket theta B plus 2 times of theta C. Here your near end will be C and far end will be your joint B. Okay. So this I get my equation number 4. So these 4 equations will be our final slope deflection equations. Now we'll move to next step, that is step number 4. Step number 4, it is conditions of equilibrium. Conditions of equilibrium are what? These are the conditions at which we can say that your moments will be completely equal to 0, or you can analyze those conditions by your eyes also. Okay. So I have told you in last lecture that conditions of equilibrium will be equal to number of decay. That is, if here having here decay value equal to 3, that means to solve this values of theta A, theta B and theta C, you will require 3 equations over there. So number of equations, that is condition of equilibrium equations, that shall be equal to 3, which is equal to your decay value. Okay. So we'll check your first condition, that at which support it is arising. So we'll start from support A. Support A is your hinge support over there. So hinge support, it is the end hinge support. So we can say that this support is an incapable support, that is it cannot resist any type of bending moment over here. So I can say firmly that my first condition is what? That your moment at joint A, that is MAB, will be equal to 0. So this will be my first condition of equilibrium, that is MAB will be equal to 0. So MAB equation I have got, slope deflection equation for MAB, right? So we'll substitute this equation over here. So what is that? Minus 13.33 plus 0.5 times of EI, 2 times of theta A plus theta B, that is your equation of MAB, that is equal to 0. So if you solve this, what I'll get? That is 0.5 times of EI 2 theta A plus theta B is equal to 13.33. This value comes here equal to positive. Further we'll modify this, that is I get my first equation, that is 2 times of theta A plus theta B is equal to this 0.5 I will get divide to this. So 13.33 divided by 0.5 I get equal to 26.66 divided by EI. So this will be my first equilibrium equation. I will call it as equation number A. Okay. Now we'll move for your second condition. So second condition will be where, as your previous numerical, that this joint will be treated as a rigid joint. So individual moment, that is addition at this joint, member BA and member BC, that will come equal to 0. So second condition will be where, that will be at joint B, or at, you can say, at support B also. So at support B, what condition I am getting? That is MBA plus MBC shall be equal to 0. MBA plus MBC shall be equal to 0. So I'll substitute the equation, slope deflection equation of BA and BC here. So first equation of BA, that I have got as my equation number 2. Okay, so I'll substitute that over here. I am getting that 13.33 plus 0.5 times of EI into bracket theta A plus 2 times of theta B. This is my equation for BA over there. Plus I'll write second equation, that is for BC, that is my equation number 3, which I am having for BC. So minus 5.33 plus 0.33 times of EI into bracket 2 times of theta B plus theta C, and this whole term, it is equal to 0. Okay, so we'll simplify this further. So what I'll do, I'll consider first constant terms over there, that is 13.33 minus 5.33, I'll get that equal to 8 over there. So if that goes on the equal to 0 side over there, so 0 minus that 8, so that I'll get equal to minus 8 over there. Okay, now I'll consider these terms over there. So I'll get this as 0.5 EI theta A plus 2 times of theta B, that is I have to simplify these two terms over there. Okay, so one by one we'll see, that is I am getting here 0.5 EI, I am taking common from both these terms. Okay, what I get, 0.5 times of EI theta A, okay, 0.5 times into 2 theta B, so 0.5 into 2, that becomes equal to 1, so I get that equal to plus 1 theta B, right? Next term, 0.33 into 2, so I get that equal to 0.33 into 2, I'll get 0.66 times of theta B plus 0.33 times of theta C is equal to minus 8 EI. Okay, so if you simplify this, what I'll get, 0.5 times of theta A plus 1 theta B plus 0.66 theta B, I'll get plus 1.66 times of theta B plus 0.33 times of theta C is equal to minus 8 divided by EI. So this will be my second equilibrium equation, that is equilibrium equation number B. Okay, now I'll require one more equation, that is my third equilibrium condition, that will be at joint C. Again same as your joint A, your C joint, it is also the end hinge support. So end hinge support, again it is an incapable support there, that is it cannot resist any type of bending moment. So what will happen, at final moment at this joint, that shall remain equal to 0. So firmly I can say that my last condition is what, MCB shall be equal to 0. Okay, mcb shall be equal to 0. I am having equation for mcb, that is my equation number 4th over here. Okay, I'll substitute that over here. I am getting that 10.67 plus 0.33 times of ei into bracket theta b plus 2 times of theta c is equal to 0. Okay, if you simplify this, what I'll get, theta b plus 2 times of theta c is equal to minus 10.67 divided by 0.33 times of ei. That is, I'll get this as equal to, I'll simplify this, 10.67 divided by 0.33. So I get this as 32.33. So minus 32.33 divided by ei as my third equilibrium equation, that is equation number C. Okay, so these three equations I am getting 2 theta a plus theta b equal to 26.66 upon ei, that is equilibrium equation number A. This is my equilibrium equation number B, and third equilibrium equation theta b plus 2 times of theta c is equal to minus 32.33 upon ei as my equilibrium equation number C. Okay. Okay. So now we'll proceed to our next step, that is step number 4th order. Or before proceeding to this step, we'll find out or we'll solve these three equations, that is equation number A, equation number B and equation number C simultaneously. Okay, so if you solve these three equations simultaneously, you'll get the values of theta A, theta B and theta C. Okay, so we'll solve these three equations over here. If you solve these three equations, you'll get theta A, that is equal to 17.07 divided by ei, positive, you'll get this. Then second value theta b, you'll get equal to minus 7.49 divided by ei, and third value you'll get equal to minus 12.41 divided by ei. So my basic aim of calculating my unknown displacement, that is theta a, theta b and theta c, are completed over here. What this negative sign indicates over here, that is initially what we have done while solving this decay value, we have considered as theta a, theta b and theta c as clockwise rotations over there. So these values, if those are coming negative, that is theta b is coming negative and theta c is coming negative, so what that indicates, in actual theta b and theta c, those are opposite in nature, that is these rotations will be anti-clockwise in nature. Okay, so these three values we are getting for your basic unknowns over there, that is unknown displacement values. Now using these values, we'll proceed to next step, that is step number 5th. We'll be calculating final moments over there. Okay, so what you have to do, you have to substitute these unknown basic values in your these four equations of slope deflection, that is equation number 1, equation number 2, equation number 3 and equation number 4 over there, and you have to calculate the final values of moment MAB, next MBA, next MBC and last MCB over there. So one by one, if you calculate this value, the first value, that is MAB, that comes equal to 0. Okay, the next value, that is MBA, if you solve or if you put these three values in your equation number 2 over there, so you will get MBA as plus 14.375 kilonewton meter. Okay, the same way, substituting these three values in your BC equation, you will get MBC is equal to as minus 14.37 kilonewton meter. Almost you will get these values as same over there. Okay, and the last value, that is MCB, you will get again as equal to 0. Okay, so substituting your values of unknown displacement, you will get these four final equations or final moments, that is MAB you are getting 0, MBA you are getting equal to 14.375, MBC minus 14.37, and MCB is equal to 0. What you have to check? You have to check whether your conditions of equilibrium are getting satisfied from this moment values or not. We'll check over here. So first condition that I have taken, MAB is equal to 0, and third condition, that is MCB is equal to 0 I have taken. So these two conditions are getting satisfied, that is MAB and MCB I am getting both values as 0. Okay, and the third value what I am getting, MBA plus MBC shall be equal to 0, that is addition of BA and BC moment shall come equal to 0. If you observe this, I am getting this as 14.375 and this is minus 14.375, that is if you add these two values you will get summation equal to 0. So my conditions of equilibrium I will say as those are getting satisfied over there. Okay, next we will be plotting your bending moment diagram by superposition over here. Okay, so for bending moment diagram by superposition, I have told you the sign conventions, that is if you are considering any member over there and this is your left hand side of the member and this is your right hand side support of the member. So if your moment comes negative, plot it on upward side. If your moment comes positive, plot it on downward side, and reverse this sign convention for your next joint over there. Okay, so we'll see how your BMT varies over here. Okay, so this is my joint A, this is my joint B, and here I am having joint as C over there. Okay, so the first moment, that is MAB. So here I will be having moment MAB and here I will be having moment MBA over there. Okay, so MAB will check that I am getting value equal to 0, so that will lie on this particular point at itself. Okay, same way next we'll see, check for MBA over there. MBA I am getting as equal to plus 14.375. You are getting positive, so where you will plot it on upward side over there. So positive 14.375. Okay, now we are shifting to next member order, that is member BC. So what will happen, this instead of AB this will become now MBC and this will become MCB over there. So we'll check over there. So MBC you are getting as minus 14.375, minus you are getting, so you will be plotting it on again upward side. So already it is done over here. Okay, and MCB that I am getting equal to 0, so that will end directly at this point over there. So join these particular points by a straight line. Okay, so what are these? 0, 14.375 and 0, these are nothing but the support moments over there. What is BMT by superposition? Your support moments are superimposed on the span moment over there. So span moment are remaining over here. So we'll calculate those. Maximum span moment for AB and for BC. Okay, so if you observe the loading in span AB and BC, so AB it is completely loaded with UDL and BC it is loaded with a point load at non-uniform distance. So maximum span moment in your member AB, that will come equal to WL square divided by 8, and same way in span BC for the point load you will get that value equal to WAB divided by L. If you solve for these two values, you will get WL square by 8, that is equal to 20 kilonewton meter, and WAB by L, that will get equal to 16 kilonewton per meter, where A will be equal to your 4 meter and B will be your equal to 2 meters over there. Okay, so in span AB you are getting this 20 kilonewton meter, that is for UDL. So nature of moment diagram in span AB, that will be your parabolic one. So 20, which will be maximum at the center over there, that is at center of AB. So I'll plot that moment value over here. Okay, so this value comes maximum at the center, that is equal to WL square by 8, it comes equal to 20. Okay, and same way in span BC, WAB by L I am getting equal to 16 kilonewton meter. Where will be this value maximum? It will be maximum at your position of point load. So point load it is acting somewhere 2 meter from your point C. So somewhere here you will be getting 16 kilonewton meter moment. So and point load it is. So diagram will be how? Nature of diagram will be a straight lines over there, or inclined lines you can say. So this value I am getting equal to WAB by L, that is equal to 16. Okay, this you get the diagram of bending moment diagram by superposition. And what you have to do, you have to shade the superimposed part over here. So this will be my final bending moment diagram by superposition. Okay, so this will be your final, that is numerical for decay value equal to 3, that is unknown at point A, unknown at point B, and unknown at point C. Here nowhere in your numerical your decay value goes equal to 0. Those are equal to your unknowns over there. Okay, if you are having any queries from this, please comment me. Thank you so much.